Okay, so let's start now. I think we started with the tuples, okay, and we discussed what is a tuple. Tuple is again a data structure, but it is immutable. What do you mean by immutable? Means it does not support an item assignment, right? Then we discuss how can we create a tuple. A simple way of creating a tuple by using these parentheses, right? Within this parentheses, we can have an integer, floating point number, even tuple. We can have list. We can have dictionaries. Okay, so it can have the wide variety of elements that are available. This is one way by using parentheses. Similar, what you can do, you can use a tuple function, and with it, then tuple function, you can pass any iterable. So it will take the elements of that iterable and make it a tuple. The way we created it, right? Means we used a list, we passed the list inside, and the list was having element 1, 2, and 3, and ultimately we received a tuple. Okay. Similarly, you passed a string inside, which is an iterable again, and I received a tuple of individual elements of that string. Right? Let me move ahead. Other ways of creating that tuple, and we saw that if we create a tuple, it does not support the item assignment. Means if we try to for example, I want to access the value 1, so I access the value 1 using t square bracket 0, that is the index. But suppose I want to assign no, means at first position I want the value 2, so it will not allow us because it does not support item assignment. Okay, so we saw two immutable data types. One is your string, okay, which does not support item assignment. Another one is a tuple, which does not support your item assignment. Let me move ahead with the same. Okay, other ways of creating the tuples. Okay, so how can we create tuples? Suppose one way, sure, we in the parentheses I mentioned the numbers, means this way point, suppose I'm creating. So within the parentheses I can mention 1 comma 2, right? So it will be a tuple. Okay, it will be a tuple, and we want to check. How can we check? We can type of point. Okay, what it will be? It will be nothing but a tuple. Other way of creating, understand everyone, two ways we have seen, by using parentheses and by using a tuple function in which we can pass an iterable. If we type this, for example, I take s, a variable name, and I put 1 comma 2. Okay, I just specified 1 comma 2. I didn't put any parentheses. I didn't use any tuple function. Still, it will be a tuple. Okay, still it will be a tuple. Means I mention 1 comma 2 comma 3, anything. If I'm putting after the comma equals to operator, and then I mention 1 comma 2, means I use assignment operator, then I put 1 comma 2 comma 3, doesn't matter, right? It still will be a tuple. Okay, if I want to check, I can again check the type of s. It is what? A tuple. It is what? A tuple. Understand, right? So not mandatory that you use parentheses. Not mandatory that you use parentheses. Similarly, but one special caution that you should take. Suppose I take another variable a. Okay, and I put 1. Okay, I put 1. So what it will be? Let's check type of a. It is an integer data type, right? But suppose instead of that, if I mention 1 comma, okay, I mention 1 comma, what will become? It will become a tuple. 1 second, let me execute this. Okay, and check the type of this. Okay, this is what? A tuple. So in interview, sometime they ask you how to create a single element tuple. Okay, they will ask you in interviews, very commonly asked question, can you create a single element tuple? So one way of creating single element tuple is you can just type your element, whatever element is, or just put a comma. It will form a single element tuple. Okay, other way, suppose I again take a variable a, put parentheses, and I put 1 inside. Okay, I put 1 inside. So okay, suppose I execute this and check again my s. What is that? This is again an integer. Again an integer, but I do this thing. S is equal to 1, but I put a comma inside, right? I put a comma inside and execute this and check its type. Okay, it's what? Tuple. So remember this. This is what? A single element tuple. Element tuple. This is also what? This one. Single element tuple. And understand, it's very, very, very commonly asked question in the interview. Okay, tell me how to create a single element tuple. Okay, and 99% do what? They do this thing. They mention that this is a tuple because we are using parentheses. Within the parentheses, we are putting 1. So it will be what? A single element tuple. But remember, it is not a single element tuple, right? We just observe what it is. It is a integer. So I put a comma here, then it become a single element tuple. So keep in mind, everyone, this is, I'm repeating again and again. If you are giving a Python interview, they will ask 100%. Tell me the immutable data types, first of all, then can you create a single element tuple? Immediately the question will be shoot to you. immediately, and very commonly asked in, especially in the TCS interview that I encountered from the across various of my students who attended the interview. Very commonly asked question. Okay, so remember how to create a single element tuple. Okay, and sometimes they also ask you this way. Okay, do one thing: create an empty tuple. Create an empty tuple. That is very easy. Nothing special is there. Suppose I mention here P equals to just these parentheses. Okay, just these parentheses, so I can execute this and I can check the type of this. If I check the type of P, what it will be? It will still be a tuple. So remember these two questions, especially this question, single element tuple, how can we create, right? One way and the another way. And this is empty tuple. Empty tuple very rarely asked, but yes, this is very commonly asked. How can you create a single element tuple? Okay. So move ahead with the same. Now suppose I have a tuple here. Okay. And that tuple is, I'm denoting by T, and it is having element 1, comma 2, square bracket, suppose A. Yeah, somebody's asking something. What one? This is an empty tuple. What one? What were you talking about this? This one? Means you want to assign this, Varun. I think if I'm correct. See, it makes no sense here. It will not be even acceptable. No. Can you see? Because we don't have any element here. So it is showing invalid syntax. So it is not allowed. Okay. Yeah, it is not allowed. So let me move ahead.
Sir,
Yes, yes, yes.
sir, why do we create an empty tuple if we cannot edit it
No, no,
in the
actually,
rows page?
it is just an interview question. Normally, we don't use it because we don't have an option. Honestly speaking, if you I create a tuple, na, see, if I this is a tuple, I think T is okay. Let me execute this. Your question is very good. Okay, actually, we don't use it normally. If you even check the method of this, see, use it. I don't have even further method. Only two methods are there: count and index. Okay, only two methods are there: count and index. But actually, in some scenario, when you can create it, suppose there is a P available, and there is a, remember, there is one empty tuple here, one T here. Okay, so we cannot element here. But if I can do this thing, P concatenation with T. Okay, I can do this thing, P concatenation with T, concatenation. Okay, so actually what will happen, your original P will remain the way it is. Okay, your original T will remain it is, because these are immutable, they cannot be changed, because they cannot be changed. But the combination of this will give you a new tuple that you can save anywhere that you want to save, suppose S. Okay, so if I execute this and I check here, my S is what? 1, 2, and A. Right? So for normally we rarely use, but actually sometimes is a scenario we create an empty tuple. Okay, and whenever somebody registered, that registration information I enter here. Okay, somebody registered, that information I enter inside the T. Okay, and then what we can check, okay, how many elements are there in P. If I do this concatenation, then we can check how many elements are now available inside the P. Earlier P was empty, so when nothing was there in the P, means nothing was even there in the T, only P was there. So the length of the P, if I want to check, see, the length of elements inside the P is what? 0. Okay, but once it has been done, I can check my S. Okay, it will show me how many elements are there. I can check it, see, like this. So 3 elements have been entered. So this is one of the use case it can be, but rarely we use an empty tuple. Your question is absolutely a good question. When we don't edit it, then actually why we need it? So we cannot edit it, right? But we can use it a different way. This is actually simple, means you can create this way, but rarely we use it. I hope it's fine. I think Ridesh.
Hardik, sir, it's
Oh,
Hardik.
sorry, Hardik,
Yes, sir.
Hardik. Yeah,
It's
fine.
fine.
Yeah, yeah. Okay. Now let me move ahead. Okay, so remember this is what operation, what we can do, concatenation between two things. Means example, I just mentioned I have a one tuple known as T, which we are just observing. Okay, and let me create one more tuple, suppose Q. Okay, and any element we are having 3, 4, 5. Okay, this is one tuple. So we have two tuples, one is T, one is Q. Okay, and I want to create a new tuple which should be a combination of these two, means concatenation. 1, 2, and A should come, then 3, 4, 5 should come in one tuple only. Okay, so remember your T cannot be altered, your Q cannot be altered, but we can do this concatenation 2 plus Q. Okay, if we do T plus Q, what I will get, see, a new tuple. This is a new tuple. Your T and Q are unaltered. If you check, T is still same, your Q is still same. Okay, they are not changed at all. But in fact, you will get a new tuple this time, which you can save somewhere. okay, which you want to save. So this is what? This is nothing but your concatenation of tuples. Okay, and it returns a new tuple. That is important. Okay, your original tuples remain intact. Original tuples remain intact. They won't be changed. Okay, they won't be changed. They will remain intact. So you want to save them somewhere. Suppose I'm saving in any other W. So you can this way, right? So if I can check my W, is there fine? Okay. Or what we can do, understand everyone? If I come here and mention this T plus Q, okay, I just mention again and I put a T here. Execute this. Okay, check my T. What has happened? Remember, because your T cannot be altered, your Q cannot be altered. Okay, can you say why it worked when the tuple is immutable? Anybody can answer this question. Why my T has changed again? If anybody can answer this question. When we are saying tuple is immutable, right? So T should not change. Then why it has changed? T has now become, earlier T was what? I think this 1, 2, and A. Now T has become what? 1, 2, A, 3, 4, 5. Why? That means, is the definition of tuple changed?
Sir, I think maybe it is more like the way when we wrote t equal to this, then the address uh, that address link has been assigned to t,
Yes,
and
yes,
when we
you are
did
going
t
in
equal
a
to t plus q.
absolutely right direction. Absolutely right direction. Others, please. Others, everyone. Other than Hardik, anyone?
So,
Varun? Yeah, yeah, please, please.
so we are just replacing the variable, but the memory location which is created by variable w, that is just shared by this t.
Yes, yes, absolutely fine. Perfect now. Okay. So what happened the moment I execute this, actually, what happened? We get a new object, right or wrong? This is T plus Q. So object has been, if suppose W does not exist for now. So what will happen if I execute T plus Q? Then object will be created, and this T is a tuple, Q is also a tuple, right? So we will get this tuple. This tuple is there, 1, 2, 3, A, and this is object will be created of tuple type, and it will be saved in a memory location. This memory location will get a reference this time, and that reference will become what? T. Okay, and what will happen with this now? Remember, we discussed that. We discussed that. That's what I'm asking you this question. What will happen with this 1, 2, and A? Earlier T was referencing. Yes, Varun, very good. Now, because nobody is referencing this tuple, right or wrong? Because earlier who was referencing that? T. Earlier only thing that was referencing what? T. Now T is referencing what? This particular thing which is available here. This. Right? T is referencing that. So there is no one who is referencing that. So it will become what? Now garbage. Okay. It will now become what? Garbage, known as garbage collection. So your interpreter will collect that. Fine, everyone? Is it okay? The simple scenario that I think in the first or second class only we discussed that. Clear? Because now there is no one who is referencing this particular thing. So it will become a garbage now. Okay. Is it clear? Can I move ahead, everyone? Tell me.
Yes, sir, clear.
Okay. Okay. Fine. So let me move ahead now. Okay. Suppose I want to access some element. This is T, which is available right now. And I think we discussed that. Okay. I want to access any element of this. How can we access this? Very simple process. The same process we have been using less. We have been using your uh, string as well. Same process. In square bracket, I have to pass the index of particular element. Okay, whatever element. Suppose I want to access this element. Okay, so what will be the index?
2.
0, 1, and 2. Very good. Simple process. Okay, the way we have been accessing. I want to access this element, then there are different ways. Either I can come 0, 1, 2, 3, 4, and 5. Right? I can do this thing. T square bracket and 5. I'll get that 5. Fine. Other way, remember?
P
In
of
square bracket,
minus.
-1. Okay, so every rule that we discuss in the string and list, same thing is working here. Even we can do the slicing as well. Okay, suppose I put in a square bracket, if I put 1 colon 3. Okay, so which element it will give me? Element having index 1 and
2.
2 only, right? That means 2
2
and
and
in
A.
A, right? So if I execute this, can you observe, everyone? Right? So absolutely same way we have been accessing that, same way you can access your tuples. Exactly same way you can access your tuples. Nothing is different there. Okay, exactly same way you can access there, right? Now one more thing. Let me come here. So suppose I create a tuple once again. and that tuple is suppose 1, 2, and 3. Okay, something like this. Okay, and I think we have already discussed that thing in a list. It is a tuple or what it is right now, everyone. I mentioned 1, 2, 3. Will it be known as tuple or not?
Yes, sir. It will be
Yes,
tuple.
I mentioned not mandatory that you put the parentheses. If you are putting the commas, don't worry. It will be treated as a tuple only, right? So if I check the type of T, it is a tuple only, right? And again, similar to the list, it can also be unpacked. Similar to the list, this tuple can also be unpacked. So how many elements this tuple is having? 1,
3.
2, and 3, right? So we can mention like x, comma y, comma z equals to directly T. Okay, this is what? Nothing but your tuple unpacking. The way we unpack the list, same we can unpack my tuple in one go. I can execute this and I can check my elements like x, comma y, comma z. If I execute this, see, I'm having 1, comma 2, comma 3. Can you observe? If I want to print them, I can print in this way. Print x, comma y, comma z. That is better. And can you see x is 1, y is 2, z is 3 because my tuple 1 will be assigned to x, 2 will be assigned to y, 3 will be assigned to z. Okay, and same rule works. Remember we discussed, suppose I want to take only one element of this. I'm not bothered about the others. So can I mention this x is equal to t? Can I mention that? If I mention this, what will happen? Remember, if I mention that, what will happen?
Whole tuple will get
Yes, yes,
assigned.
yes. Okay, so this means same object is there. On that object, one more reference will be assigned. That will be x. Okay, so whole x will become your t only, right? Same thing. But if I mention this x comma y is equal to t, is it allowed? Tell me everyone, is it allowed? X comma y is
No,
equal to t.
no, sir. It is not allowed
See, let
because
me execute this. What I get? Error. Too many values to unpack. Expected 2. Because it has 3 values, right? So t has how many values? I think 3 values, right? And how many variables you have used? 2, right? So it is not allowed. So what I can do? Remember what we discussed? I can put a comma, I can put a star, and I can put what? Others. Okay. If I execute this time, it will work the way we want, right? It will work the way we want. Execute this and check it. Okay. If I have X, it's worked. I have Y, it's there. And rest everything which is available will be packed inside this others. Okay. So if I execute this others, fine. Can you observe? As a list. So rest of the elements will be packed as a list. I think the same thing we discussed in the list as well, if you can remember. Exactly same thing was there in the list, right? Exactly same, nothing difference is there. So list can, your tuple can also be unpacked the way you were unpacking your list. Okay, exactly same way. And same your in operator. Remember we use our in operator inside your string. Same in operator we use inside our list, and same in operator we can use inside this. For example, if remember we mentioned that p in Python. Okay, so what it does is check this p is present in this Python or not, right? This is what a list, this is what a string. So if I execute this, it returns true, right? If I check here q, which is not there, it will return me false. We have done that, right? Similarly, instead of this, if I pass a list here, commas 1, comma 2, comma q I pass inside. And again, same process I do. Okay, this q is available in this particular list or not. So I can do that again. See, I will get a true. Once more. Okay, so I can use my in and not in operator the way I was using inside my list. Same way I can use inside the tuple. So suppose instead of list, if it is a tuple, instead of list, it is a tuple. Same will work without any problem. See. Okay, so this in operator is working in almost every sequence. We just saw it is working with a Python. It is working with a Python, that means a string. It is working with a list. It is working with a tuple as well, right? So this in operator is applicable in any sequence is available in that particular sequence. You want to check whether this element is available or not. You can easily use in and not in operator. Both are available there, right? Very, very simple. You can access them, right? Because sometime it may be needed that we want to check in a particular tuple, this particular student is available or not. Okay, so how can I use that? I can use this inside what? Because it is returning true and false. So where I can use this, whenever something returns true and false, I can pack inside if statement. Okay, and then I can print exist. Okay, we can mention that if it is this, I can say Q and concatenation operator, I can mention exist. Okay, say Q exists. Let me give some space, that is better. Q exists. Okay, so sometime it may be the case that your tuple is given to you and you have been asked, tell me whether this particular person is available in this list or not. For that purpose, you can use what operators? Your in operator. Okay, now come here and let's check create a tuple. Let me check the T. What is T? T is very simple. Let me create some more elements. 1, 1, 2, 3, 4, again 2, 4. Example. Okay, let me execute this. And let's check the method of the tuple. Only two methods are there. Let me press tab. If I press tab, only two methods are available inside this because it is immutable, right? So very few methods, only count and index. What the count does, let me press C and press tab. Autocomplete. Go inside and read what it is saying. I have to pass a value. Okay, I have to pass a value and it will return what? The number of occurrence of a value. Number of occurrence of a value means how many times that value is occurring. How many times that value is occurring in this particular tuple. Suppose I pass here what? 1. Okay, so how many times this 1 is occurring in this particular tuple?
Q.
2 times. Okay, so it will return me that number. Okay, simple, very simple function, nothing specific. How many times it is occurring? If I pass 3 here, because 3 is occurring only once, I will get
1.
1. Right, so let me execute this. I think very, very simple, everyone. There should not be any doubt in this.
Yes, sir.
Here, let me move ahead. And similar function is like this, T dot, again tab, index function. Okay, so as the name saying, it is going to return me the index. Go inside, and it is very much similar to your list as well. See, value, start 0 or stop index. Start index and stop index. Same thing we have done. If you create a list here, see, L is equal to 1, comma 2, 1, comma 2, comma 3. Okay, and I come here and check. Same thing we have discussed already. L dot index. If I go inside and check, can you see the syntax, everyone? Exactly same thing. Value, start index, stop index. Exactly same thing is available in the tuple. Value, start and stop. So exactly same way it works, right? Means default it takes it is. I will search from beginning of the tuple till this particular index, and this is very huge. I don't think so you will be ever encounter that. So it means I will search from search in the entire tuple, okay, and give the first time that value you have passed is occurring. For example, I may pass here 2. Okay, so if I don't pass my start index and stop index, it will search first time when it is occurring from the beginning. Search here when it is occurring, this here occurring, right? This is occurring here. So what is the index, everyone? 0, 1, and 2. So if I execute this, what I get? Tell me, everyone. Clear?
Yes, sir.
Clear, sir.
Right? Simple. Similarly, if I want to get this too, now you can tell me what should I pass here? Should I pass something or not? If I want to get the index of this,
You can repeat T dot index
yes,
again.
yes, yes. Inside this, we can pass T dot index of
2.
2, but it will give me what? If I just use this, will it work? If I execute this, see, I'll get the same number because, but I want after this
Plus one.
actually. Yes, I want to add it +1. I want to add a +1. Okay, so if I execute this, I get 5. 0, 1, 2, 3, 4, 5. I think it should be clear, everyone.
Yes, sir.
Okay, same thing we discuss in that case. Okay, and one more thing, actually, that is very, very easy. Suppose I have two variables here. Okay, come on, yeah, x and y. So suppose I create x is equal to 10. Okay, I use y is equal to 11, and suppose I want to switch them. Okay, I want to switch them without use of third variable. Getting my point, everyone? This is x, this is y. I want to make x to be 11, y is equal to 10 by using what? Without use of variable, third variable. With the help of third variable, we can easily do, right or wrong? Within 1 second, we can do that with
Yes,
the
sir.
help of third variable. It's very, very easy. But suppose without help of, this is actually also an interview question. Okay, again, an interview question. This is without the use of third variable, swap the values without use of third variable. Okay, and if we studied the tuple, I can do that in 1 second. How? We know that if I mention x comma y, what it will become, everyone? A tuple, right or wrong? We saw that
Yes, sir.
it will become a tuple, right? Now
Tuple.
what I do, if I unpack this tuple, I mention y comma x, done, right? This will be
Yes.
a tuple, right? This will be a tuple. I just unpack. So first value will go to the y, second value will go to the x. So if I execute this, it's done. Now you can check print. For example, directly you can check y. It see it has become 10 now, and your x has become 11. So very commonly asked question in the interview. Without the use of that variable in the Python, can you switch the values? Your answer is yes. Within one line of code, we do that because we know that how a tuple is created. If I mention x comma y, it will be a tuple. So I can just unpack that and my answer will be there. I hope it makes sense, everyone.
Yes, sir.
Okay, very, very simple. Now come to another data structure. Okay, I think this is the tuple. Come on, yeah. Let me come here. And that is your, select this, yeah, your one, that is your sets. Space. Okay, this is your sets. Fine. So what is a set? Understand each and every line, see properly. It's actually very, very beneficial for you. Very, very beneficial. It means beyond your imagination, it can solve your complex problem statement within few line of code if you know the sets. So what is a set actually? Understand? It is it is a, and sorry, it is an unordered, that is important. Unordered. First very important thing. It is an unordered, and let me pack them inside the quotes. Unordered, okay? Collection of, unordered collection of, again, what? Unique. This is also important. Elements. It is an unordered collection of unique elements, means order is not there. Okay, earlier to that we have been using tuple. Okay, we have been using Python, we have been using list. This was ordered, means if I create a list, see this, L is equal to 1 comma 2 comma 3. If I ask you, please, I want to access this one element, tell you can, how easily you can access, how you will put
By
L
index, L of
instruct, yes,
0.
0, because you know that it is particular ordered, it will be always available at the 0 index. If I use Python a string, right? If I say, please give me this T, so you can access that very easily. How? By passing the index of that. What is that? 0, 1, and 2, right? If I create my tuple, the same way I created, suppose, let me convert directly this list into a tuple. Okay. So I'm creating a tuple T is equal to tuple, and let me pass directly L. Done. That is there or not? Oh, sorry. I typed in capital tuple. See, it has been done. And if I check my T, this T should be, sorry, this T. This T should be there. And if I put a square bracket and I want to access this too, I can easily access, right? How can I access this too? Everyone tell me, how can I access this too in the
T of
tuple?
1.
T of 1, right? So everything was ordered. You were able to access them. But in sets, there is no order, remember. In sets, there is no order at all. In sets, there is no order at all, okay? This indexing won't be supported. This indexing won't be supported there in the set. So first of all, that is important. It is unordered. So your indexing will not be supported. Suppose, let me create a set. Okay, first of all, a simple set, let me create. Let me show you how to create a set. I can create a set simple. Suppose set name is S. With, we use curly braces for the set, creating the set. And I put, suppose, 1, 2, 1, 3, 4. Okay. See, I intentionally entered 1 twice. Okay. And let me enter further more elements. P, commas, 4, 5. Again, let's say 4. Okay. So if I create this set has been created. Okay. Let me check the type of this. Type of S. It's a tuple. Sorry, capital S. It's a set, right? It's a set. Now see, if I check my S, okay, you will see there will be no duplicate elements. Means I entered 1, 2, 1. 1 was twice, no? 1 was twice. 4 was twice. But if I check this, only 1 I will have, and only 1 4 I will have. Can you check? Is there any duplicate element? See, I entered them, but I am having only unique elements, no duplicate elements, right? And similarly, if I try to access their order, me suppose it looks like, okay, it should be at 0 index, right? Let me check this. S square bracket 0. Execute this. See what it is getting. Set object is not subscriptable. Okay, because it is unordered. The way you are seeing right now, you cannot guarantee that it is at this position. Next time it may give you different result. Okay, and if you people know about the DBMS, database management system, or the SQL, if you have studied how it has been designed, it is designed using your set theory only. Okay, and that's why the result that you use, the select statement you write there, your result is not guaranteed. That's why the order by clause has been put there. That's why the order by clause has been put there, right? Intentionally, though your SQL is in fact derived from your set theory only, set theory and predicate logic. Okay, so it has been derived from set theory only, where order is not there. There is no order. Clear, everyone? These two things are important or not? Please, these things are clear. Unordered collection, because it is having various elements, right? We are having several elements, that's why it's a collection. And second, why unique element? Because it can have only unique elements. So these 2 points are clear. What is
Yes, sir.
unordered and what is unique? And see how it can be benefit. It can be several time benefit. It can save your precious time of writing the code. Okay. Suppose I have two lists. Take an example. Okay. I'm telling you. What do you mean by that? Suppose I have a list known as L1, in which I have some elements 1, 2, 3, 4, and then 2 again, 4 again, then 3, again, then 5. Okay. I have one more list, L2. Okay. And again, I have some elements, suppose 3, 4, 2, 3, 4, 5, 7, 8. If I want to say, please give me the common element between these two lists. Okay, please give me the common element between these two lists. Okay, so how will you do normally? Okay, I will compare the first element with all the elements, right or wrong, everyone? Tell me.
Yes, sir.
Right. Then you will compare the second element with all the elements. Then you will compare third element with
All
all
the
the element. Then fourth element with all the element. Fifth element with all the element. But you see what you are doing, you're wasting your time, because you want to search what are the common elements I want. Okay, so common element, if this 2 is matched here, already matched here, should I do this 2 again? Check. Tell me everything. Because
no.
2, we want to search what? We want to find what? We want to find the common element. So 1, 2 is matched here, or 2 is doesn't match here. Means once the searching has been done with the 2, should I do it again? No, it should not be done. Once the searching of 3 has been done, should I do again? But I should not done. But if I use it directly, of course, it will be a loss of time, lots of time there. So what I can do in such cases, if I execute this, see, I should remove duplicate element from this. I should remove duplicate element from this. And how can I remove the duplicate element in 1 second?
Convert it.
Yes, convert into the set. So if I make S1 example is equal to, okay, I can use again the function set function this time. Okay, set function and pass my L1 inside. Similarly, I can use my S2 equals to again set function, and I can pass my L2 inside. If I execute this, okay, and check my S1 and S2, S1 comma S2, let me put it. Can you see? Check everyone. How many elements we are having? 1, 2, 3, and 4, and 5 in what? S1. See, the duplicates have been removed. Similarly, from here, if you observe, there is no duplicate. Can you observe anyone? Right? So duplicate is gone. Once the duplicate is gone, you can take back your list back. How? I can say, okay, my L1 is back again. What? List of what? S1. My L2 is what? Again, list of what? S2. Let me execute this and let me check back my L1 and L2. L1. See, only and only list of unique elements. Again, L2, only a list of unique elements. Now we can compare them, and I think my precious time will be saved.
Sir,
Yes, yes.
but this doesn't mean that we have got a data loss.
No, why? Actually, purpose is what? Remember, it's not a loss. What is the purpose? What was the purpose? You want to keep them, don't make it L1 and L2, you make it, give a different name. Because suppose he says, no, I want a new list. You want L1 to be like this, L2 to be like this. Then you create an immediate intermediate step between S1 and S2, and then you give a different name, no problem. L3 and N4. If you want to preserve them, if you want to preserve your L1 and L2, don't
Okay,
worry.
okay.
Use L3 and L4. Now L3 will be this, okay, and L4 will be this. I hope you get a sense, everyone, right? So now you can find a common element and save the result. In other memory, your original result will be the way it is. Okay, fine. So your original list L1 and L2 will remain the way it is. They will not be altered at any cost because you're not touching them. Let me show you that. If I execute this once again, this again, this again, G L3 is this, L4 is this, but your L1 and L2 is the way it is. They are. This is the original. See, and similarly, if you check L2, L2 is also same. Fine.
Okay.
Okay, so remember, this is very easy method to create. Remember, anyway, how do we create that, right? Similarly, what I can do, I just pass inside my set. Okay, one way I just mentioned, you can use these curly braces. Within that, you can pass the element. Your set will be created. Very simple way. Other, you can use your set function. Within that, you can pass an iterable. Okay, that will create a set, but removing the duplicate element. Suppose what will happen if I take again, suppose a variable name is A, I use again the function set. I want to create a set, but I am passing an iterable here. Suppose my name, Praveer, which is what? A string. Okay, so it can be passed here. Okay, so what it will do? It will give me a set of the elements of this, but after removing
Duplicates.
duplicates. Okay, so if I execute this and check my A this time, see, I have duplicates R in my name. R is appearing only once. Okay, I have E duplicate, so E is appearing only once. Okay, so any iterable you can pass inside the set, but remember what it will do? It will remove the duplicates from them, and order is not guaranteed. I repeat once again. Okay,
So
order is yes.
another thing is happening when you are converting it into a set. It is automatically sorted. All those elements are getting automatically
No,
sorted.
it is sorted, but don't rely on that. But don't rely.
Okay.
Don't rely on that. It will be sorted like this. Don't rely. Okay, don't rely. That's set. The definition of set is that unordered. Okay, otherwise we can always use the index. Getting my point?
Yes, sir.
Otherwise, we would have used the index. If order is guaranteed, that means we can use our indexing, and that is not supported here. So although it is giving that way, but I always advise don't rely on the same. Don't rely on the same. That's why it is not given. Fine.
Okay,
Hope it
sir.
is fine.
Sir,
So yes.
sir, can we point out my set data type with dictionary?
Sorry. I'm not getting what you mean.
Like if I want to point like in dictionary we are having key and value pairs.
Ha.
So can I associate my set
Means you want to
this
create a
set with
dictionary. You can want to create a set from your dictionary, right? If I'm correct.
uh,
That's what you want to do. Suppose
something
I
like
pass.
that?
Don't worry. Let me do that. A colon 10. Okay. And let me pass one more. P colon 20. And intentionally, I will pass some duplicate records. Okay. Although in dictionary, again, if I try duplicate, it will immediately itself showed an error. Suppose I create a dictionary directly here. A colon 10. It will not allow me to have duplicate keys. Let me again create A and 10. Okay. And suppose I am giving it a name, suppose D. Okay. It allowed fine. Let me check the D again. It is removing, right? Can you see automatically because it is not allowing the duplicate records? Can you check? Let me make it 20. Let's see what happens in this because it allowed me this time because we are having the same 8, 10 and 10. Okay, let me execute this. So it is allowing D is equal to 10, but let me make it 20 because we can have only unique key. Okay, let me check what A is given. It is taking only one value, right? It is taking only one value, this one value, only one value. I think the larger value only, but it is not always we should have a unique value only because only unique keys are supported. Otherwise, how will you access? Suppose I put here, I create this list. Okay. If I use this A here, then what will happen? How will it recognize which key you want to access? This or this? It will not be able to identify. That's why a duplicate key should not be entered. Okay. This will not, it will enter only one, but let us no issue. Let me create this set. I just passed A here 100, B is equal to 20, and let me save it somewhere. Suppose Q. Okay, execute this and let me check my Q. So what it is accessing, it is giving me only
Keys.
keys. Okay, it is not giving me the values. I never used it because it's actually not required for the same purpose, because we already know the purpose of the set is different, right? Set needs to have unique elements. Okay, and in dictionary also we need to have only unique keys. So already those things are already there. That's why normally it is not used. But yes, you asked, then it should be clear. Okay, it is keeping only.
Yeah, so that's why I
Uh, uh,
asked in the
uh,
first place, because
uh,
of uniqueness of both. So, sir,
yes, yes.
can we like assign my set function instead of like, can we represent my, can I represent my set with one key value only?
Sorry, I'm not
One
getting.
key value,
Yes,
like
yes, yes, yes. Means only one key value, na, like this.
like if I'm creating a dictionary D
Uh-huh.
and I'm having a set, whole set, and can I represent that set with only one key value? Like A equal to A, then
Yes,
colon,
yes, yes.
and then my whole set.
You can have anything here. Here I can have even a list. See, 1, comma 2, comma 3, comma 4, comma 5. See, if I create a dictionary now, you can have anything.
Hmm.
Actually, we have not studied dictionary. That's why no problem. But let me show you that. I can have any element here. Okay, it's a list, it's a data structure. Okay, so let me execute this and see it is available. If I check my queue and pass in the square bracket A, the key, see the complete list is available. Okay, even I can pass here a set like this, no problem. Any data structure you can have here. Single elements you can have, even you can have your uh, data structure. Okay, let me execute this. See, done. If I check it, can you observe?
Yes, sir.
Okay, yeah. Okay, we'll come to the dictionary. Don't worry. After the sets, we'll come to the dictionary only. Okay, but no problem. Okay, I think we're getting an idea now. See, let me create two sets and see what are the actually use cases when the sets will be very, very important. How much helpful they can be for you. Okay, so let me create a one S set known as S1, and in this set, let me put some elements like 1, comma 2, comma 3, comma 4, comma 1, comma 2. Okay, and let me type another set. S2 is equal to again. Suppose this is 2, comma 3, comma 4, comma 5, comma 6, comma 2, comma 3. So can you tell me what will be S and what will be S1 and what will be S2 if I create those? You can answer me, right? What will be S1 and what will be S2 if I execute these statements?
S1 will be 1, 2, 3, 4.
Yes, very good. And S2 will be
2, 3, 4, 5,
5,
6.
6. Yes, absolutely perfect. Okay, if I check this S1 and this is S2. Okay, perfect, perfect. What happened now? These are sets now. So in the mathematics, we have studied the set theory. And whatever operation was supported in the set theory, all those operations can work here, like your union, your intersection, your difference, your symmetric difference. Everything can work on this, your sets. Example, the use cases. Okay. Suppose what is happening, I have a student list. Okay. And suppose student name is known as cricket. Okay. In this cricket, the few students participated. Okay, and suppose this is the list right now. The list is given to you. Okay, normally the list will be presented to you because ultimately we are going to work on our columnist or our table structure, that is the pandas. In that pandas, every column is represented as a series, and series is like a list only. Okay, so suppose some names are given to you, and those names are suppose my name. Okay, I participated in the cricket. Somebody else, suppose Hardik, participated in the cricket, and somebody else, suppose Anusha, participated in the cricket, and suppose there is one. Varun participated in cricket, and there is one more candidate. Suppose Vanchika, she participated in the cricket. I have one list available. I have one more list available. Suppose of soccer. Okay, and few students again participated in that. One is Praveer. Okay, second one is suppose Varun. Okay, and few are the new students. Okay, suppose Arun, who is not present in the above list, and then Amit, and then suppose let it be four. No problem. Okay, yes. Let's take an example. What is the purpose? Purpose is what? Your boss says, okay, the list is given to you. This is one list. This is one list. Okay. They say that, okay, these are my student. And suppose this is a data set of a college, because most of the people belongs to college only. Few are from industry, but most of are you from college only. And the task is that I will give the sports marks. Okay. There are marks section and we will assign them the marks who have participated in the sport. So give me the list of those. Okay. Give me the list of those who have participated in the sport. So what do you need? You need the name from this list and you want to name the take the name from this list. Understand the scenario, everyone. They need a list, okay, in which the name should be there, okay, whether he's participated in the cricket or whether he's participated in the soccer, his name should be available in that list. Means you want something like this: Praveer, Hardik, Anushka, Varun, Anshika, okay, and others. What are those? Praveer has already come, so Varun has
And
already
Amit.
come. Arun and Amit. Okay, this is my requirement. Okay, this is what your boss wants. Okay, means take the all the elements of cricket and take all the elements of soccer and remove duplicates. Okay, this is the requirement list. So I want all the list. Okay, so what I can do directly doing is very tough, although we can do that, no problem, but directly we can do that, but with the help of set theory it becomes very easy. What I can do, I can convert these lists which are appearing here, okay, into my set. So suppose set s1 equals to set, and I pass my cricket inside. Okay. Similarly, I take another set known as s2 and convert this soccer into again into a set. Okay, let me execute this and I can verify s1 is this set. Okay, and s2 is this set. Fine. Now what I can do, remember in the set theory there's an operation known as union. There's an operation known as union operation. What union does, okay, this is one set of values, this is another set of values. So what union does actually, it takes the all the elements of set 1 is like this. It takes all the elements of set 1, okay, and takes all the elements of set 2, okay, and after taking all the elements of set 1 and set 2, remove duplicates from this, because that is a property of set, right? Property means duplicate should not be there, so it will remove duplicates. So what it will remove, it will remove Praveer and Varun, right? Because Praveer is repeating and Varun is repeating, so it will remove these. So this will be my final list what I want. Okay, this will be my final list what I want. So what I can do, once they are in a set format, I can quickly do what? I can do union operation. Okay, so what we will do, we will do union. First, everyone understood what is union? Take all the elements of set 1, take all the elements of set 2 and remove duplicate. That's it. Fine. So what I can do, just a second, everyone. I think Prabhakar sir is calling me. Just give me a second, everyone. Yeah, fine, everyone. Right. So what I can do, I can do what? Union of these. Suppose I mention here print. What? Union I have to take now. I will take S1 and I will take a pipe operator. A pipe operator which is above the enter. This operator. And mention S2. So it will do what? It will do union. So if I execute this, you will see that I will get this kind of this kind of result. What I mentioned. Okay, let me execute this. Okay, although it may be sorted here and there, doesn't matter, but the elements will be the same. Can you check, everyone? How many elements should be there? Praveer, Hardik, Anusha, Varun, Vanchika means 5 and 6 and 7. So 7 elements should be there. 1, 2, 3, 4, 5, 6, 7. Can you see? Praveer is not repeating, Varun is not repeating. Clear, everyone? Right? And if you want to save the result somewhere, it's your choice, right? I want to save the result somewhere. Suppose I'm going to say this is my S3. So I will take the union of these. I will save in the S3. Done. And I can check my S3 once again. Okay, so my S3 is this. Now he's saying, no, I want the list back. Fine, take the list. It is available with me. So I'm gonna say, okay, combined list, combined equals to what? Just use which function? List function. Okay, pass S3 inside, execute, you'll get back your combined list. Fine, everyone?
Yes, sir.
Right? Similarly, another task now, this time. Same task is there.
Sir,
Yes, yes.
before going ahead, I wanted to ask one thing. Can you just scroll up?
Sure.
Here, in line number 111,
Uh-huh.
we had two lists, cricket and soccer. And then we have created two sets separately.
Yes.
So can we do this by using that unpacking format using zip function? Because we have lists. S1 comma S2 is equal to zip of that cricket, soccer. Like that, can we do it in one single?
No, what will help it out in that case?
No, instead of just getting these two separately, suppose I have got big lists, say around 1,000 elements in first and 1,000 elements in second. Then doing this separately will involve a lot of time.
No. It will actually, if you are doing unpacking, that will become very tedious for you in that case. How will you write? How will you write those 1,000? Just trust. How will you write those 1,000? X comma Y comma Z comma something. You will get crazy, right or wrong?
Oh, yes.
Right?
Right.
You will get crazy that way. This is the easier. We don't have to touch anything. Right? So let me see. Now, second scenario. Okay, this was the combined list. Now requirement is show me the list of students. This list is what? Means the student who participated in any sport, right? Who student who participated in any sport. And remember, you can use this pipe operator, union operator. If you have one more set, you can use one more pipe operator. Remember that. Okay, so no limitation that you can use only two. If you have three sets available, you can further use. If you fine, is it okay, everyone? If you want further, you can achieve that. Okay, remember that. So you can have those further. Similarly, let me get now. He's saying, show me the list of the students who participated in both the matches, both the sports. Okay, earlier was what? Show me the student who participated in at least one of the sport, right? Who participated in at least one of the sports. That is fine. Now it is saying, show me the list of the student who participated in both the sports. In both the sports this time, right? So what we need to search common elements. Right or wrong, everyone?
Yes, correct.
Right. This time we want to search for common elements. So we have two sets already available, S1 and S2. Okay. We want to search common elements. Okay. So how can I do? First, same process is there. I will convert them into the list, into a set already done. One way I can use a for loop and I can run, but that will be very tedious. Instead of doing that, actually, okay, we have two lists available. This is one list. This is second list. I want to search the common element. I can use same process I can achieve with the help of for loop, but actually that is a tedious, a complex code I have to write, right? But beside then that, if I convert them into the set, my life will become very much easy. Very easy, right? See, so already we have set S1 and set S2, which is there. Now I will use an operation known as intersect operation. Intersect or intersection. Okay, it gives common elements. It gives common elements. And very simple. See, if I print what S1, I have to use a M% operator. Okay, I have to use a M% like this. S1, S2. Okay, if I execute this, can you see? Only two persons are there who participated in both the sports, and we can verify from this, right? Only Praveer and Varun are those who participated in both the sports. So common element in 1 second which is achieved in 1 second, right? And I can save it anywhere in one. I can save it in a other set, suppose S3. Okay. And or if you want, we can directly use this and we can directly pass here what? My list function. Okay, so we know that S1 and S2 is going to give me what? A set only, right? So I can directly use my list function here if I want. I can say one step, means directly I can use because I need ultimately I need a list now. So list of this. This will give me this time if I want to print my S3. This time it will be a list having only Varun and Praveer. Check everyone.
Yeah.
It will act as the intersection.
Yeah, I'm saying, see, it is what it is intersection only.
Okay.
It is an intersection operation. It is an intersection operation only. Right? Similarly, okay, what I need this time, suppose I need uncommon elements. Right now we get a common element, right? Now I need uncommon element between the sets or between the list, whatever uncommon elements I need. Means those students who participate in exactly one sport, exactly only in one sport, exactly in one sport only, means he should, means what name we should get? We should not get this time Praveer, because Praveer has participated in both the sports. We should not get Varun because Varun has participated in both the sports. So I should get only uncommon element, those elements which we have participated in only one of the sport. Okay, so again same thing. I can use what? Symmetric difference this time. This is known as symmetric difference, right? So what I can do, again same thing I can do. Suppose I want to print S1, okay, and this time I will use a caret operator, and this caret operator is available above the sixth key, the sixth key that you are having in the keyboard. Above that, a caret, okay, and I can mention here S2. So other than Praveer and Varun, I should get everyone. See, Praveer is not there and Varun is not there, so these are what? Uncommon element from both the sides. Okay, or those students who exactly participated in one of the sports. So three different results we obtained, right? Three different results. What union give me? Okay, means give me the list who participated in at least one of the sport. In at least one of the sport, right? This give me what? Those students who participated in both the sports. This give me what? Those students who participated in only
exactly in
one of the sports. Clear, everyone?
Yes, sir.
Right? Remember that. And you want to, again, you have to convert into the list. So one go, you can convert that. In one go, you want to convert that. Okay. Similarly, there is one more thing. Let me come here. That is actually very simple. Suppose I have this list, right? I want to check. Tell me those students, okay, those students who are present in this list, okay, but are not present in this list. Okay, who are presented, who participated in the cricket but did not participate in soccer. Clear, everyone, what I'm saying? Those students who participated in the cricket but did not participate in soccer. Okay, so what I can do, I can use a difference that we call it as a difference this time. Okay, so we come here, difference. What is the difference? Nothing but very simple. S1 minus S2. So I have two sets. Let me execute this. Okay, and let me print this. What is this difference? And check what is my S1. Let me actually bring upside so that you can see the difference directly here. Yeah. S1. This is my S1 and this is my S2. Okay. So check, everyone. Come from the Anusha. Anusha has participated in the cricket, but has he participated in the this thing, everyone? Tell me. S2?
No.
No, right? So her name should be there. Yes, it is there. Come to the Hardik. Hardik has participated in the cricket, but has he participated in the soccer? Again, no. So his name should be there. Come to Praveer. Praveer has participated in the cricket. So has he participated in the football? Yes. So his name should not be there. Okay. Again, Vanchika. Okay. Vanchika has participated in the cricket, but has she participated in the soccer? No. So again, her name should be there. Now, Varun. Varun has participated in the cricket. He has also participated in soccer. So her name should not be there. Means I need those elements of this list or this set, which is not available in this set. Clear? Which are not available in this set, that we can achieve with the help of difference. Clear, everyone?
Yes, sir.
Okay, so these are different use, and you can use a different way. For example, I solved one of the problem of a client in which this is a very simple problem. Actually, I used solve them with the help of said SQL only, but same problem was giving. What happened? It was a very simple problem, barely 5 minutes problem. So they had actually an event. Okay, they had an event in which they first of all they asked to their employees, please register. Who want to participate in this event? So almost 5,000 people registered on this. That was a huge organization. Okay, and then they have day one attendance, then they have their second day attendance, then they have third day attendance. Okay, so they asked me, sir, can you help me in something I can within quickly, because 5,000 manually doing will be very much crazy even if we don't want to use a SQL. Can you automate it something? Means within one go I want to know, out of the total person who registered, okay, on the day one, means they registered 5,000, how many attended the day one, how many attended the day two, how many attended the day three, means out of the 5,000, out of those 5,000, how many attended, right? Because it may be possible they also made it open on day one also, means when the event started, some people can come and register on that day directly on the event. So they are not available in that 5,000 list, which was created at the when the announcement was made. So they were not there. So in your list, the same list is not there. And when the event started on the day one, the people may come externally and join. So if those names are also available there. Okay. Similarly, day two, people may come from the external, they may join also. In day three, also they want to join. Okay. So they don't bother about the external people. They say, no, only my reference is this 5,000 people from my organization who registered now, but list is complete. Their organization as well as outside. So you have to find out first of all, out of 5,000, how many came on day one? Show me their name. Show me the name who come on the day two. Show me the name who come on the day three. Now show me the name who attended at least one day of the event. Okay, show me those days who attended at least one day of the event. Right, this is one task. Show me those names who attended at least, or who attended all the days. Who attended all the days, means day one they were present, day two they were present, day three also present, and also show me those person who didn't attend even a single day of event. Okay, so same logic you can use there. Anywhere your problem can be solved. Not only in, right now we are seeing in this set theory, you can use it anywhere. Wherever your data analysis problem will be given, you can solve them. I solve with the help of SQL because their database are maintaining in the SQL only. Okay, so same thing you can do at top everywhere if you understand the logic. Is it fine, everyone? So far, any doubt in this? Okay, so we'll continue tomorrow from here. Okay, is it fine?
Okay, sir.
Okay, everyone. Okay, bye bye. Take care, everyone. Thank you. Yeah. Okay, bye bye, everyone.